Hello students and YouTube learners, this is your friend Dr. Satish Singhal, PhD, Professor Computer Science at Community College, Torrance, California. Now I'm in the second part of design example lab 2 on monthly payment on a loan taken, video 2 of 2. In this one we're just going to take a line of algorithm and we're going to go to our compiler and show you how line by line we can convert our algorithm to source code. And better quality's algorithm, better quality our source code would be. Algorithm is the foundational document for the source code, and a high quality algorithm shouldn't take more than 15-20 minutes for this size of program anyway, to complete the program actually. Alright, so here is our algorithm, and I'm just gonna take line by line, copy and paste the line into compiler and do the source code accordingly. Okay, so first of all, let's go to our compiler. When you write programs, I would like you to always include this information: your name, like my name, in your case your name, and the class and section number, name of the project, date you are finishing the project, not the starting date, finishing date, which compiler you used, and which operating system you have used. If you have any problem, that will help me to kind of look at the problem a little bit easier. And then you do all your includes, int main, and return 0 at the end. You can make this as a standard file, and anytime you do a lab or any other program, you can just copy and paste there and just go from there actually. So that'll save a lot of time. So just do that in the future. Okay, so now I'm going to take line by line from the algorithm, convert to source code. Okay, copy and stay with me, don't get tired. So that is simply double loan. Notice I didn't make this uppercase because in my documents input table later on in the formula and everywhere it was the lowercase. Don't worry about these status messages because it is thinking I'm not going to use it. I will. So don't worry about any of the messages you see here. Just focus that here. Okay. Then declare rate as double, and I'm taking the longer route here so you can see step by step how easy it is once you have good algorithm. So I'll say double rate, and then we keep going. And what I can do all these at once and just go like this, and don't worry about these, will all get commented out. I can do that. Didn't want to do group commenting because I have to put source code statements in between. Declare num payment PMD as int, so I'll just do int num int. Okay, here I don't know what I used, so I'm going to go back to my algorithm and see whether the spelling was same or something different. Okay, so actually I have to go here. It was lowercase and uppercase, that's what it was. So okay, So that's what I'm going to use. And this will happen that sometime I'll just copy and paste it. Dollars and an int, so that's pretty easy. Int dollars. Cents is an int. Total pennies as double. And finally rounded pennies is int. I'll just copy and paste that. Okay, I think all my declarations are done. Okay. I guess I can't do anything about these status messages. Don't worry about it. Okay, then let's go to number 2. Step number 2. Go to algorithm. Print message greeting user. You have some flexibility in that. You can again decide that here or later. So I'll do something like this: cout welcome to monthly payment on a loan program. Okay. Then print so you're prompting them to enter the amount of loan they took. So cout, and really all I can do is just take and copy and paste that. That was in Word, so it didn't accept, so I had to change the quotes. Okay, and then acceptance store into loan variable. Number 4. So notice that we are going in that sequence 1, 2, 3, 4. This way also you're not forgetting to do something. So cin loan. So notice these status messages will disappear as soon as I have used one of them. See? So there was a status message for loan that disappeared now. So that's why I'm saying don't worry about these. Okay, number 5 in percent, and here it says show an example. So I will do that. So that will prompt is done using cout, enter interest rate for loan in annual percent. Now I'm going to use that other advice, that show them the style. Okay. For 7.2%, enter 7.2. So that way they know exactly how to enter. We already have a variable called rate, so we'll do C in rate. Done. And this message will go away. Okay, then we have that conversion to monthly. So our step 7 is this. Yeah, actually I forgot one step. This one. I was being faster than I should be. Yeah. Don't be too fast, okay? Now number 7. This. Rate equal to rate divided by 1200. And that I can just copy and paste, really, because that doesn't have any quotes. Quotes are the one that don't transfer well. Done. Okay. We go to number 8. Number of monthly payment. So, sorry. Actually, I could go a little bit up like this. Prompt is always done using cout. Enter number of monthly payments. And number 9 will be accept and store input non-PMT variable. So I'll be doing that here, C in num-PMT. And your compiler will have this auto-completion software. See, it will show you already declared variable. If I, in my case, if I enter key, it'll auto-complete it, and it is done. So that's why it's not a disadvantage to use long names, because after typing few letters of the beginning of that variable name, you'll get the auto-completion option, and you can just hit the enter key or tab in Windows and autocomplete. 10. This one is exactly, I can just copy and paste that, although since I'm doing an algorithm step, I will show that too. But really all I have to do is just get rid of this and put a semicolon here, and I'm done. That's my computation. Okay. Output raw monthly payment, I can do that. Oops. Here. See. Now here you see the advantage of numbering. If you number the algorithmic steps, you're not going to forget anything. That's a huge advantage. Okay. In the beginning, you need to make sure you don't forget anything. Okay. And if some compile error is made, let's say I forget the semicolon, expect a semicolon after the expression, so it will just point out to me right then and there, and I can fix it right then and there. And I think there's a fix option here. The computer is so smart. I think I will just have computer do it for me. Fix, and it did it. See? So many times it will give you option of, at least in Xcode, it gives you option of fixing it too. This is the most powerful feature of writing pseudocode algorithm, is step by step, having its own numbers separate, that you can put them, at least in the beginning, you'll find it pretty convenient that you're not going to forget anything. Okay. Output raw monthly payment, that's done using cout. raw monthly payment is units of dollars. Monthly payment auto completion. Okay, 12. Now we have algorithm to round off to nearest penny. I can put the whole thing there if I like, but really it's enough for me to go to 12.1 because 12 is broken down into several parts, and I can just take that. Now if I declared total pennies earlier, actually I have, then I don't need this double here, so I can delete the double, don't need it, and that's that. Actually here in algorithm also I don't need this because I declared them at the top. So 12.2 is this. Delete that. Just take that and copy and paste that. Terminate to the semicolon with the semicolon. That's that. Keep going. 12.3. And that is already declared. Dollars is already declared. Everything is declared. So this will work fine. Notice I haven't had a single compile errors yet, which will show up with the red line, because algorithm was written so well actually. Of course, I'm not saying that you should worry if yours doesn't come out that perfect. As I said, 6 years and maybe 10 rewrites, maybe more than 10 rewrites. Okay, so 12.4 and that. Okay, and now step 13, which is the last one, is printing dollars and cents. So here, print, see out every comma is arrow, quotes are as it is. These are variables, quotes, variables. So you can recognize in this whole thing the what our various components are. Your monthly payment. This is the variable dollars. Each comma is changed to cascaded operator. Auto completion dollars, but we do tell them that many dollars, and cascaded cents. Anything in quotes is the string. UL is end of line. Well, I think it's a good idea to say goodbye, although it's not my algorithm. Okay, so algorithm was written well, and I have practice in typing, no red lines. So let's compile the program. If there are errors, it will tell me. I don't think there are. So we have a dialog window. It's a little slow, but it will come up. Okay. Yeah. Welcome to monthly payment on a loan program. Enter the amount of loan to be taken. So I have some data, I believe, at the end. Take $10,000 loan. Comma separators are not used. We have to write 10,000 like this. Interest rate, so 8.1. Number of monthly payments, 60, that is 5 years. Notice there was a fractional penny in the raw, but that should be dropped off because it's less than 5. So dollars and cents did that, and we got $203.24. Okay, so I want to show you that algorithm, excuse me, which we used here. Okay, so we had this, and then we follow this algorithm. Then we get total pennies. So we get this value. So I'm just going to do that somewhere here in the comment section. So my total pennies will be equal to this. Oops. I actually just want to copy that. Into 100. That was my this step here. And if you're uncomfortable with case sensitivity, I can change that. And that is equal to 20324.3. Then rounded penny was int of total pennies plus 0.5. So total int of total pennies, which is this value here, which is effectively int of uh, 0.8. The 0.3 plus 0.5 is 0.8. So what does casting to int means? Just throw away the decimal part. So this will be equal to 203 24. So next is dollars equal to rounded pennies divided by 100. And that's 20324. Replace that with this one. So what will be the quotient of this division? You can do longhand, whatever, at home, but really I clearly see that quotient will be 203. So I get $203. And then last one is cents, which will be equal to 20324 modulus with 100. And that gives you the remainder. So if you do the longhand division here, remainder will be 2. So that's how this algorithm step 12 works actually. And at home you should practice it the best you can. Okay, I did 2 of those. We'll get rid of that. And the program will still compile. File, save. I'll run it, but I think I won't input the numbers again. So so that's how the step 12 algorithm is. Step 12 algorithm demo. Okay. People get confused with this, but take a look at here and the step 12 here. It will become pretty clear to you how it works. Amazingly, nothing else works. We have tried other ways. I'm telling you, any other algorithm will fail somewhere. This is the only way. It always works, always works, always works. Okay, so thanks for watching. I'm done with this video as well, where I took the algorithm and did the step-by-step source code conversion. And this will be uploaded, as well as the document that I showed you earlier will be uploaded as well. And 2 videos, 2 documents, and you'll have the whole picture in front of you. And with that, I'm done. Thank you for watching.